My name is Idini, and today we are going to be going through mass spec and IR. So when reading mass spec, we start from the right-hand side of the graph and work our way towards the left by first finding the heaviest molecular ion on this compound here. So number one, it's going to be the MT value, and we're going to find that value to be right over here. For this molecule, it's going to be 100, and it's going to be at the very right-hand side of the graph. So our MT value is 100, and then the next thing we have to calculate find is the base peak. The base peak is going to be the highest relative intensity on the graph, and we see that this intensity is going to be around there. It's around 69, so we're going to put 69 here. And the next thing we're going to have to try to figure out is the possible formula for this molecule, so that we can maybe draw a structure. So we're going to start with the mass, which is 100, and then we're going to have 2 oxygen atoms, each 16. It's going to be 32, and we're going to end up with 68 remaining here. And then we know we're going to have carbon molecules, and we can fit in 5 carbons of 12, because that is the atomic number of carbon. It's going to give us 60, and then we're going to have 8 remaining. So we know this 8 remaining is... So here, our structure is going to put it over here. We're going to have 5 carbons, so we're going to make 5. We're going to put a double bond here, and we know we're going to have hydrogen. We're going to have a double bonded O. Have 3 more hydrogens over on this side. So now when we look at our formula, we had 5 carbons, which we have here in this molecule. 5 carbons. We've got 2 oxygens. And then we also have 8 hydrogens. But here we've only shown 6. So the remaining hydrogens are going to be right around here. And so this would be a potential or reasonable structure for this molecule. Next, we're going to look at IR. So when we look at IR spectra here, we actually read the graph from the left-hand side to the right. It is important to note that we have 5 zones on these graphs that give us key pieces of information that tell us what functional groups we might have in our formula. So the first zone number 1, starts from around 3700 and it goes to about 3200, which I have highlighted here in black and labeled number 1. Here we're going to look for alcohols and functional groups of that nature, and as we can see here, we don't have any significant dips in our wavelengths, so we're not going to have any alcohols in our structure. The second zone is from around 3200 to about 2700, and here I have highlighted in red and numbered it with red. We actually are going to see that we do have a significant dip here, so this is evidential of carbon to hydrogen, sp3 bond here. So then we're going to move on to the third zone, which is going to be from around 2300 to about 2000. And here, so we've got about 2300 to about 2000. That's going to be zone 3. And here we're going to have alkyne groups, so C triple bonded to another C. And as we can see here, we don't have any significant dips, so we won't have any of those in our structure. The fourth zone, which I will highlight in green over here, is going to be from about 1850, so about here, to about 1650. So till about right here. And here this is interesting because we do have a lot of action over here, 2 dips, which can mean that we could have ketone, aldehydes, and an ester. So from this, we can conclude that in our structure, we're going to have an ester group, which is an O double bonded another O to a carbon to another carbon. The fifth group we're going to see here is going to be from 1680 to about 1450. And here we're going to have double bonds. So I'll highlight this in yellow from about 1680, about 1450. So right here, it's going to be the fifth group, and I forgot to label this one. This was the fourth zone. And this was zone number 5. And here we're going to have alkene groups, so carbon double bonded to another carbon, or an sp2. So carbon double bonded to carbon, sp2. And these will be all of, and then after zone 5, we have this region here, which is known as the fingerprint region, and we don't pay too much attention to this region. We just focus on zones 1 through 5 and see which functional groups are evident in these zones. So when we did the mass spec, I gave you a possible structure that could arise from that chemical formula. And now we're going to just make some more sense out of that and see where those functional groups came from. So as you saw in the IR diagram, that we are going to have an ester group. We did have carbon double bonded to another carbon, and then we did have carbon single bonded to a hydrogen. So sp2, sp3. So now we're going to redraw our structure that you saw earlier, and we'll see how these functional groups fit in our structure. So we had the chain, and we had the oxygen here coming off to another carbon, double bonded oxygen here to make the ester group, which is highlighted right here. Then we had the carbon double bonded to a carbon. And then we're going to see the carbon bonded to hydrogen on all these parts right over here. So then you got one hydrogen here, one more hydrogen here. You're going to have 3 more hydrogens over here. So as you can see from the structure, we do have an ester group, we have carbon double bonded to carbon, and carbon single bonds to hydrogen, which correlate to the IR diagram that was shown earlier. So then, our final formula for this was C5H8O2. And here we can verify that this is our structure by looking at this formula. We have 2 oxygens, 1, 2. We have 8 hydrogens, 1, 2, 3, 4, 5, 6, 7, 8. And then we're going to have our 5 carbons. So 1, 2, 3, 4, 5. Thank you for watching the video, and I hope you enjoyed.